Hello everyone, today is day 17 of solving a LeetCode problem every day. So today I solved generate parentheses. So you're given an integer n and you must return all well-formed parentheses strings that you can generate with n pairs of parentheses. So this kind of goes back to the question from before where you're given a string and you have to check whether the string is valid based on whether it has matching open and closing delimiters, and you do this using a stack. But the only difference with this question is that instead of being given a string, you have to generate all possible numbers. You have to generate all possible strings that have n pairs of parentheses that are also valid. So this is how I pretty much did this solution. So I still use a stack, and let me make this a little bigger. Cool. So I still use a stack. So I initialize a stack and I initialize output array. And basically I have three conditions because I did this recursively. So basically my base case is that if the open number of parentheses is equal to the closed number of parentheses, which is also equal to the number of pairs that need to exist, I just, to the output array, I add what's currently in the stack. And then my other case is if the number of open parentheses is less than the number of pairs that need to exist, I append an open parenthesis to the stack, and then I go ahead and recursively call this method again, except with one more open parenthesis. Then after that, I pop. And similarly, with if closed parentheses is less than open parentheses, I append a closed parenthesis to the stack, and then I recursively call the backtrack method with another closed parentheses, and then I pop. So I'm going to give a little, I guess, drawing to kind of help explain what is going on over here, because I feel like this can be a little confusing. But what I'm kind of doing is building out a tree. So let's say n is equal to 2. And I'm sorry, my handwriting is going to be horrible just because I'm writing this with a mouse. But if n is equal to 2, what you're basically going to do is your first is open, like we start out with calling 0 open parentheses and 0 closed parentheses. So they are equal to each other, but it's not equal to n, which is 2. So you continue, but open parentheses is less than n, which is 2. So what you want to do, start out by adding an open parentheses to the stack. And then we restart because we call this with now, let's say open parentheses is equal to 1 now. And then we go back again, open parentheses is still less than n, so we're going to add another open parentheses to the stack. And now this is going to be 2. Now we go back, they're still not equal to each other, but now open parentheses is equal to n, so we skip this. But closed parentheses is less than open parentheses, so we add a closed parentheses. And then we call this backtrack method again, except with one more closed parentheses. So let's say this is 1 now, and we go back. This is false, but this is still true because closed parentheses is 1 and open parentheses is 2. So we append another closed parentheses to the stack, and then we call this backtrack method again, with this now being 2. So pretty much what happens now is we go here and they are equal. So we append what's currently in the stack to the output array. So in this case, we'd append this. And then we return. So now we're back here because that's where we were last. And then we pop. So pretty much what we're doing is we go backwards 1. And now we go back again. And this is where we were, and then we pop again. And what we're also doing is we pretty much just reset this back to 0 because we just went back 2 in the recursion stack. Oops. And then now we're currently here. So we'd be here. What we want to do next is this is going to go back to 1. Because when we called this method here, we called it with open parentheses plus 1. So this is open parentheses is still equal to 1 over here. But what we're going to do now is pop off the stack again. So we go backwards. And we see now that closed parentheses is less than open parentheses. Like that case is true because closed parentheses is 0, but open parentheses is 1. So what we do is we're going to append a closed parentheses to the stack, and then we call this backtrack method recursively again. So we go back here. We see that we called it with closed parentheses plus 1, so this becomes 1 again. But now, so open parentheses is equal to closed parentheses, but it's not equal to n, so we can skip this. Open parentheses is less than n because right now, open parentheses is 1 and n is equal to 2. So we want to append the open parentheses to the stack. And then we call this backtrack method again, except with open parentheses plus 1, so this becomes 2. So we go backwards again. This is not true. This is not true because now open parentheses is 2 and is equal to 2. So now we're down here and we see that closed parentheses is less than open parentheses. So we append this to the stack and then we backtrack again, but this is 2 now. So now we're over here. Open parentheses is equal to closed parentheses and they are both equal to n. So now we also add this string right here to the stack, or to the output array, which would be open parentheses, close parentheses, open parentheses, close parentheses. And now we're here, so we can pop. So we go backwards 1. This goes back to 1. And then we were here again. Now we were here. So now what we want to do is pop. So we go backwards. But if you guys don't remember, when we were back over here, 1 open parentheses over here was equal to 1, and closed parentheses was also equal to 1. So pretty much this case isn't true, and we just go back again. So now we're back over here, and we pop again, and then we go back to the very beginning, which is right here, where open parentheses is supposed to be 0 and closed parentheses is also 0. So we just can finally pop that off the stack too, which would be this. And then at this point, we'd return the output array, which is this. Cool. So yeah, that's my solution.